0. Okay, field lines due to two negative charges. Well, this time I'm going to have two negative charges. The only difference is the field lines, instead of converging onto the charge, in the case of positive charge, the field lines were diverging from each. In the case of negative charges, the field lines all will converge to the negative. So the only difference between this and the previous case is that the field lines are now converging to the negative. In the previous case, they were all diverging from the positive. Otherwise, the nature of the field is exactly the same. The resultant field due to two equal points negative charges is similar to the field due to two equal positive charges, except for the direction of the field. Alright? Field lines due to two opposite charges. If I have a negative charge and a positive charge, how will the electric field look like? Well, look at this. That is the positive, that is the negative. A test charge placed near the positive will move away from the positive and towards the negative. So the field lines originate at the positive and terminate at the negative. Isn't that beautiful? What a beautiful pattern of field lines. Now, you should also try and understand this. The strength of the field is much stronger where I am circling with my pointer and much weaker over here. And what can you say about the strength of the field in between the two charges? You can see the field lines are very nearly parallel there. So you have an almost uniform field in between the two charges. Why? The field lines originate on the positive and terminate on the negative. In the region between the two charges, the field lines due to both charges are in the same direction, because the positive will push the test charge away, the negative will attract. So look at the direction of the field lines in between there. The intensity of the field is high in this region. The field lines are very close there, and so the strength of the field will be very high in between the two charges. Okay. Look at, I have got some systems in here, and see whether you can understand these field representations. Look at this one. Here I have one positive charge and another positive charge. Can you tell me what is the difference between these two charges by looking at the field lines? Well, first of all, there are a lot more field lines originating from this positive than the one on the left. What does it tell you? It tells you that this is a much greater charge. You see, the number of lines of force originating or terminating on a charge is proportional to the quantity of charge. So this is a much bigger charge than this. Alright? We had a similar negative charge situation. Which of these carries a greater amount of charge? The one on the left or the one on the right? Obviously the one on the right, because large number of field lines are concentrating on it. Look at the third one. A positive charge and a negative charge. Tell me which of these charges carry a greater amount of charge? Well, the amount of charge is proportional to the number of field lines either originating or terminating. You can see the number of field lines terminating on the negative are much greater than the number of field lines originating at the positive. So obviously this negative charge represents a much larger quantity of charge. And how about this? Which of these has a greater amount of charge in it? Obviously the positive charge. Okay, now that you understand the basics of electric field lines, I'm going to give you an exercise, and this is the exercise. Several electric field lines patterns are shown in the diagrams below. Which of these patterns are correct? Explain what is wrong with each incorrect diagrams. Now, each one will earn you 1 extra credit point. Alright? I'm just going to show them to you, and I will leave them for you to answer and send them to me. You have this all on the PowerPoint, so I'm going to go a little fast. You look at the PowerPoint and then answer those and send them to me. Alright, here is the first set of diagrams. Diagram A, diagram B, C, D and E. You got to see which of these patterns are incorrect. Explain what is wrong with the incorrect diagram. Okay, that is number 1. Number 2, John drew the following electric field lines for a configuration of 2 charges. What did he do wrong? And explain. So this is the second assignment. Each one will give you 1 point. It's very silly actually, because it's so simple. Okay, you got to tell me what is wrong with the diagram and explain. Consider the electric field line shown in the diagram below. From the diagram, it is apparent that object A is dash and object B is dash. In other words, does it tell you anything about the type of charge carried by A and B? That is what I expect here. Alright, that is number 3. Number 4. Consider the electric field lines drawn at the right for a configuration of 2 charges. Several locations are marked on the diagram. You need to rank these locations in the order of the field strength. In other words, which point the electric field is strongest, which is the weakest. Now you got to arrange those points in some ranking order. Now here are the points. Point A, B, C, D, E. You got to rank them according to the strength. Which of these 2 points has the field strength greater? Looking at the field pattern. Alright? That is number 4, I think. Alright, 1 more. I think there are 2 more. Use your understanding of electric field lines to identify the charges on the object in the following configuration. You got A, B, C, D, E, F, G, H, I. You need to identify the type of charge carried by each of these charged objects by looking at the field configuration. And finally, observe the electric field lines below for various configurations. Rank the objects according to which has the greatest magnitude of electric charge, beginning with the smallest charge. So you put the smallest first and then go in the order of increasing amount of charge. Alright, we got objects A, B, C, D, E, F, G, H, I, J. You got to say which has the greatest amount of charge in each of those. So there are 6 assignments that carry 6 extra credit points. So send them to me within a week and you can earn those points. And also go through and refresh these ideas. All the ideas that we discussed so far are going to be used in the next few lessons. Alright, so you must be very, very thorough with the concept of the definition of electric field, the definition of field lines, the definition of electric flux, the definition of electric field using flux. Is that right? Field strength. Electric field is flux per unit area. So all those concepts are very important. Alright, I'm going to stop this one here. I will see you for the next part of this lesson, which will be calculations using electric field concept. We will calculate electric field due to systems of charges using the formula we developed in this lesson. Alright, I'll see you for that in a little while.